Yes. Hello, everyone. Thank you. This will be in English, but I'll do a short, because we're in Quebec City and we're all mostly French. I'll do a short joke, I hope, with French at the beginning. So if you speak English and you hope to, have good content, great content today, be aware already that it's not going to be the whole thing in French. Mais je tenais à dire en français que hier, on a participé au CTF et pendant le CTF, on s'est rendu compte qu'il y avait une équipe qui s'appelait les Olivier Bilodeau, puis qui était septième. Puis là, on était comme, oh my god, on est en train de se faire battre par une équipe qui a mon nom dedans. Ça, c'est pas juste. Puis nous autres, on s'appelait Trio Montréal B-Sides Montréal avec Croquette. Un long brainstorm qui a donné ce nom-là. C'est vraiment compliqué, je ne m'embarquerai pas là-dedans. Mais là, on a tranquillement, à mesure que la journée avançait, on s'est mis à rattraper les Olivier Bilodeau. Puis là, j'ai continué à documenter ça sur Twitter. Puis là, un moment donné, on était collés. Puis pendant longtemps, on a été très, très proches. Puis on a fini, bien sûr, par les battre. Mais là, c'était pour combien de temps? Puis là, finalement, à 3 heures du matin, les Olivier Bilodeau ont été meilleurs que l'équipe qu'il y a Olivier Bilodeau dedans. Ce qui est quand même bizarre. Mais je juste à dire un shout-out à la gang, incluant Charles Hamilton qui était dans cette équipe-là, que j'ai trouvé ça vraiment drôle. Puis c'est flatteur aussi, tu sais, qu'une équipe a ton nom dedans. Puis c'était comme genre, qu'est-ce qui se passe? What the fuck? Comment? Oui, oui, clairement. Oui, oui, c'est ça. Le nom, c'est pour me troller, là, c'était clair. Là. Tout à fait. C'est vraiment volontaire de leur part. À moins, en tout cas, le contraire me surprendrait. Donc, so with all that said, let's do this. This is a wild ride of a talk. It has a lot of stuff in it. It's like, when you apply for 50 minutes, sometimes people are like, oh, I'm going to fill this with memes or stuff. This doesn't have room for that. So let's just start right in. So some pictures of me and I brag about stuff. RDP, all right. RDP, we are remote desktop protocol. Everyone's familiar with it, but still, I want to have it visually. So you connect on a system using a client, specific client, and it allows you to manage. So it's the SSH equivalent for Windows of remote management, and it's important that it shows pixels. So it's like not just text, but also mouse movement, display, and stuff like that. So it's a lot of layers and it's very complex, and we all implemented that in our attack tool we're going to talk about today. But we're not going to dive in the details, right? We are about end results, how to protect it, and how to understand it. And this is not about the middle layers, which are complex and implementation details. So when we talk about the layer that matters for us today, I/O encompasses display, keyboard, and mouse. So I/O is all like input, output. We have also clipboard and drive. So it's a very big protocol, has a lot of attack surface. So that's what we're going to talk about today. So virtual channels are another important part of the protocol of RDP. And all of it, so when you connect, all of the virtual channels are set up and dispatched, and they all have specific purpose, and they all have features accordingly. So the I/O channel here again is display, keyboard, mouse, but you have device redirection, clipboard. Clipboard is very important and very cool as an attacker, and important to understand the implication as a defender. So the security, like security in a sense of logging in, if you want. The wire protocol, which is a super legacy, it used to be RC4. So this is like broken by design, more than 15 years old. Forget about this, and no one sees this on their network today. Now, the one that is legacy that should be off your networks, but is still exists, is the second mode, so TLS plus graphical login. Yes, this is the TLS as in certificates and HTTPS. This is the same TLS that is used, so the RDP protocol is wrapped in it. But there are a couple of design decisions that Microsoft made that are questionable, that shows that they weren't thinking about risks the same way as they are now. So when you log in with TLS, what is cool is that clever, I guess, is that you get the whole graphical login. It means that if you change your Windows version or your authentication protocol entirely, it doesn't matter, because when you connect, you get the display, the keyboard, the all the things. But the problem of that is the attack surface. Imagine all that code that handles pixels and stuff is available to you before authentication. So this is why they designed the third thing, which we're going to talk about a lot today, TLS plus network level authentication. So the authentication is before, so all that code is not exercised necessarily. And this is the modern authentication mechanism for RDP. And NLA is a famous option. You'll see a screenshot later for RDP security. Now that's the wire protocol, and this is still like today the what's deployed everywhere. Now you have additional security mechanism after you authenticate. For convenience, the password is stored in memory on the server, on the RDP server that you connect to. And you have additional feature to protect that password or remove it entirely. These are also important, but they are kind of additional and disabled by default. But so in one slide, this is RDP security, but we're gonna dive in attacking, pieces of that just right now. So monster in the middle, the legacy RDP. Let's do that. Okay. Now you can do a security downgrade attack. NLA is not enforced or enforceable by the client by default. Is this blurry? A little bit, but no, it's not too bad. Okay. So yeah, so if you are in the middle, if you meddle with the network, you can say, oh, I'm gonna remove the NLA bit from the server's message, and the client is just gonna take it, love it. And so the risk here is if your users click through warnings. The warnings are numerous and scary. So this is, a practical attack if your business is used to click through things like that. But if not, then it's not a practical or realistic attack. But the impact, and this is why we created PyRDP, which I'm going to talk about shortly. But the impact is massive, right? Display, keyboard, clipboard. You can take over on the server side. You can steal files on the client side. And I have some stuff I need to implement, but we could drop file on the client side. This is a technique I'm going to cover later. Now, here's a demo of all of that impact that I'm gonna try to go through, and it is a lot of things, different things that are done. So on the left-hand side, right-hand side, what you'll see is we run our PyRDP monster in the middle tool, and now we launch the player. So the player is an optional component. You don't necessarily need it, but it makes for a better demo. On the left-hand side is a client. So we're gonna open RDP a client. We're gonna connect. So here, what we have is a warning first, because I am sharing a drive letter. Yeah, it is blurry. So we are sharing a drive letter. Unfortunately, Windows, the RDP client, you can't select a folder. You have to share your whole drive. So I share my whole C drive in this example. And now this gives you an additional warning, more so than just the certificate error. So we have this first warning, which is legit, right? Which Microsoft added, and it's important. Now you have the certificate error. So of course I am being under attack. So the certificate is not legit and the name doesn't match, although we generate a certificate dynamically. Now, as you see, as we talked about, this is the graphical login, right? You enter your credential this way. This is not a machine level interaction that happens with it, which means that all this code is exercised. This is my point about the NLA and why it reduces attack surface. So all that code is exercised. Now you enter credentials, and since we are attacking, as you can see on the right-hand side, or you might not see, but we have like everything is logged, right? We have the password in clear text, all of the key presses, and we have a pixel perfect representation of the screen that the user sees. Now, credentials are collected using a heuristics because we can't rely on it because it's all clicking and dragging and pressing enter. It's not a protocol, so we have them like when you press enter after X time, we decide okay, this is probably a credential. And now you can see that all of the things that I type are intercepted, right? So the password for the key pass was super secret, and it's all intercepted by the attack tool. So this is one of the risks is input, like keyboard input and all that is collected if you are under attack by this technique. Now, going on, another risk is the clipboard data. The clipboard data is a bit nasty to understand, but let me try to explain quickly. So the RDP client subscribes to the clipboard update information on the client side. So my Windows VM, anything that happens in that VM, it will that updates the clipboard. It will say, the OS will say to the RDP client, hey, there's a new clipboard. And the RDP client has to tell the server, this is how this feature works, right? So the RDP client says to the server, I have a new clipboard. Are you interested in it? And our attack tool just says yes all the time. That's what we do. It's just like, new clipboard, good. Now, the thing that is also nasty, that is, I think, less understood, is that also if with VirtualBox, I share my clipboard with VirtualBox, it's the same process. So what you have here is I am using on my host, I am putting stuff in the clipboard. The VM is made aware that there's a new clipboard and says I want it. And the client, RDP client, says there's a new clipboard, and my attack tool says I want it. So what you have is a pure stealing mechanism that I just that yeah, you just miss. But so yeah, as soon as I copy Veronica, like I just did the Control C, and boom, I collect the clipboard data instantly. Now, that's, you know, for pen tests and stuff like that, red team exercises, that's not that cool. But for honeypots, it's magic. Like, you collect so much stuff. Because the guys, they attack you, they connect to your thing, but then they update a clipboard of like infected list, and they copy and paste IP addresses, and then they brag about it on Telegram, and you steal all that shit, right? It's amazing. Now, the next feature I want to demonstrate or talk about is the client-side file stealing. So I am browsing right now on the right-hand side the file system of the client. And now I am dumping a secret file to my attack machine. And this is possible because the whole drive was mapped, and because it's a whole drive, again, adversaries share their C drive, and I'm able to look at it and go through it. There are some kinks that or problems right now with the code that when it's big, I'm not able to slurp all the stuff, but I'm working on that, and eventually I'll be able to, like, you know, expose a lot of adversaries online, I hope. Um, Now this is all about to show you that it's legit, right? So you see the content. So this file was located on the client side. Now I'm gonna open it on Notepad to show you that this was really that it's not a staged demo. It's the real thing. So we can see. Okay, yeah, it's the client side information that we have here. We're almost done. The last part is the takeover, I think, if I recall correctly. So we are in the middle of this connection, and we are using the player. So there's a button called take control. And then what we do is we freeze entirely the view that you have on the client side. so you can do whatever you want. It just looks like it's stalled, that it's buggy, and you can do whatever you want on the sending side. What we advise people should do is open a shell, run a payload, and then close it. The reason is because we're corrupting the RDP cache as we do so. And you can see glitches happening on the client side. So you need to be careful because there is a very important cache happening with RDP. And if you corrupt it, the person will be like, there is like glitches and stuff, what's going on? Disconnect, reconnect, and then you're just out of the way, and you can, have whatever secret you wanted to have. But it's important to know when you are doing a take control that you need to be very careful with what you do because the client will see corruption, screen corruption. Now, this was an attack on a server that doesn't enforce NLA, okay? Now let's move on. So there was a noticeable certificate error. So all of this was by the tool PyRDP, and here's a bunch of links. The slides are going to be available. Another version of this is already available online. Now, how can you defend again that Tradecraft? Normally, you should have a username and password input, but instead you got the certificate error first. So this is a way to realize that something's going on. Okay. The degraded flow is certificate error and then a login. So you know that there was not NLA involved in this exchange. It's a bit technical, right? It's for the geeks. So graphical login instead of NLA. But what is NLA? So let's dive into that. So one thing that you guys should check is it enforced in your enterprise settings and your configuration? And it's kind of important. But the reason why NLA is important, I already mentioned all of them. So attack surface reduction, less DDoS because you don't allocate all the memory that you need for the screen. You want authentication first. So it's more like internet robust if you want. And it's by default since Windows Server 2012 or Windows 8. So the attack surface reduction that I talked about, all of this is removed, right? And this is a lot of stuff, a lot of code that all could have potentially 0 days in it, So, or that is being fuzzed right now probably by researchers. So NLA gets rid of all of that, which is good. Now, the protocol, which we're not going to dive into this morning in deeply, but it supports both NTLM and Kerberos. I'm not very good with Windows systems, so I don't know well the Kerberos part. I have ambition to understand it more. I need to understand it more. But the attacks that I'm going to describe are all around NTLM, not around Kerberos. I don't even know how it works. But so this is the NTLM exchange. And you have basically a very small challenge response protocol. And so for those who know, this exchange is called a net NTLM v2 exchange. Now, if your target has NLA, we can do an NLA downgrade. So we just remove the option of NLA in as the messages are passing by. And if the server doesn't enforce it, it will pass. Now, most servers now enforce it. So the technique or the defense, the blue part of this is you need to have this by default, right? It's the default today, but sometimes for various reasons it's disabled. But these reasons should be revisited right now. And here is how to do it via PowerShell. There is a group policy, and the group policy, what I really like about it is that it's graying the box. After you can no longer remove the setting, like an administrator cannot disable it. So it's great for that. Okay, but now we were facing this, mitigation, and we were realizing if the client doesn't enforce it, then it means that we can still attack it, right? And so we figured like we can redirect. So when PyRDP is in the flow, of course, being a monster in the middle attack, we always need to be in the network flow. But so if we detect that the server enforces NLA, we can redirect transparently to another server. And guess what? This works. The thing is, the user realizes he's not on the good system as soon as he log in, but you already have his password, right? He authenticated. So you win. Now, I was like, this is weird. Is there a way to prevent that? And again, I'm always dealing with Marc-André Moreau, the guy who created, it happens to be a guy from Montreal, Quebec province. But so this guy is the guy who created FreeRDP, is the legend on RDP, and he's a very big Twitter user. And so I kind of, as I was working on the stuff, I was like, it can't be possible that it's that bad, right? And he said, no, there's no specific way to enforce it on the client side. And I was disappointed. So sad trombone. But now, as we were thinking about this, we realized there could be a way, maybe given specific conditions, because, okay, so yeah, let me give you shortly the full story, is almost nothing attacks the downgraded version, the non-NLA RDP online. And personally, my goal was to collect cool stuff from online adversaries. So the fact that I didn't support NLA was bad. And here's, I think, why. When you're a hacker, you want to create a script that hacks, you scans internet and hacks systems. Having to implement the fact that, oh, I have a display and I need to go at and type text in a specific input using scan codes of keyboard of the 90s. Like, it is difficult. Whereas if you attack an NLA system, the authentication is part of the protocol. So you can just do, I implement this specific piece of the protocol, and I try usernames and password there, and I have my response instantly. So this is why we implemented the NLA bypass. We were not attacked by hackers, or not as much as I wished. And I saw the RDP connections, and I saw that there was not as much as there could be. So we revisited the NLA diagram. This was a brainstorm session at the office where we were like, fuck, there's a way, I'm sure. And so what we realized is, if we have the private key, so the PK in this slide, we can mimic 100% of the endpoint. Now, you realize this is a pretty big if, but private key of the RDP destination server, right? But for honeypots, we happen to control all that stuff, right? So it was possible, and we did it. And now I'm collecting cool shit online. So I'm gonna show it to you. It's short because it's focusing on the NLA. The difference here is that I need to pass the private key, so a certificate and private key here, and then the client will connect. So all of this will be different than earlier. So okay, warning because I map a drive, and then boom, we get the dialogue that is a machine level. So this is on the client side clearly, and now the error is different, right? We have only one warning, and the name in the certificate matches the intention of the person connecting. And we started on the right-hand side. You can see that we started collecting NetNTLM SSP hashes. So we have the crypto, the authentication mechanism is being stolen. And now if the password is correct, the person has access to the system, but we all collected that. And so this is a full-on attack of RDP with NLA. Again, the caveat is huge. We need the private key of the system. And there was still a certificate warning, right? Where is the quit on that thing? When it's overlay of my own machine plus the thing, it's confusing. All right, so still a noticeable certificate error. And now, what we advise is, okay, use certificates. So on Windows, you can use the certificate management system of Windows. Again, I said I suck at Windows. I want eventually to have these steps laid out. But as a geek, I tried Let's Encrypt instead because it's easier. Don't need for domain, and it works, right? And we there's a way to do it via DNS, so you can even use it. You can use Let's Encrypt for internal hostname. Here's a link to a blog post that describes how to do that. But still, it's impractical. Windows admin, I think, should know better than me and use the CS services from Active Directory to generate certificate for their machine. Now, I was like, I just used Let's Encrypt to sign certificates that were valid for RDP. I can probably use this to attack, right? So I tried, and it worked. So here's how to do it. You install the certbot tool, and you use that certificate in your attack. And these are the step-by-step. And now we're getting close to a pretty nasty situation with RDP, right? So now it becomes a game of phishing or of social engineering. You need to convince the target that he wants to connect to your RDP server that you control. But if you are able to do that, then you control all the parts, right? So warning, because the drive is mapped, connection, no error, no certificate error at this point, and then boom, you're in. And the padlock is there, right? So this is a full-on attack with NLA, with proper certificates on RDP, where we intercept all of it. It's bad, but can get worse. We realize that, and again, it all depends, right? I don't want to sound too brag or like everything has like the fact that you need the certificate, the private key of the certificate of the server is a pretty big caveat, right? So I want you guys to all realize and understand that risk. So RDP is not completely broken and fucked up, but it can be attacked. We can scratch it, and we've done it pretty good. Now this one here is a bit different. So the risk, so compromising the server is interesting, but nowadays a lot of the game happens with hashes, right? You launch responder when you are on a network that you are trying to attack, and if you get hashes, you can crack them pretty quickly now, with the powerhouse graphic cards that we have at our disposal. And the hash is kind of an end game in itself now, right? It's important, and it allows you to do other things. So this attack is the last in the sequence that I'm going to talk about, but it's it's sad that the situation is like that. And when we figured it out, it was so bad that we advised Microsoft. I contacted Microsoft. I was like, it shouldn't work like that. I'm not comfortable with this. And they said it works as designed. They said like, yeah, this is like what we, yeah, this is the NLE. This is how it works. So the thing is, like, we figured we can just fake a challenge and send the bits and get the net NTLM challenge from the client. So why don't we lie? Like, even if we don't have the private key of the client, why don't we lie with a fake challenge to whoever is connecting? And this in itself was obvious, right? We looked at the protocol chart and we were like, it's gonna work. But what was not obvious is that I'm getting ahead of my slides. So yeah, we can crack, and we can collect the hash and we can crack. Okay, so in the prevention here is like, oh yeah, but we're gonna advise the clients to don't click through certificate error. That's the fix. That's how this stuff is not gonna happen. And then we tried. The problem is that the certificate error happens after. So you connect, you get the prompt, you fill in a password. In this case, I'm filling on purpose a bad password. But you can see on the right hand side, I got a net NTLM v2 exchange. And there was no error. Now I'm going to try the good password. And what's weird is that since we don't have the private key, this just corrupts whatever is happening on the client side, right? The error is obscure and it's weird. But like you can see that I collected the hash. So this was, whoop, too fast. So this was the correct password. And I'm not good at this, so I don't even understand what's going on. I could like quit cleanly after this point, but I didn't. I'm just like, I got the hash, yeah, YOLO. Now the error on the client side is like an internal error has occurred. And this corrupts the state of the client, but this is just a tangent. What I want you to realize is that you got your hash stolen and you never had any clue that it was going to happen. You don't have a certificate error, don't have nothing. So the takeaway of this here is RDP, it's finished on untrusted networks. It's finished. No one should use it, right? It's broken. Now you absolutely need to use a VPN or some measure to trust your network. You can't rely on RDP otherwise. And Microsoft said it's as designed. I expected to get, a couple bucks as designed. And to be fair, Responder implemented a variation of this attack. This is where we got like the idea that we could do it as well because we're really deep into RDP with PyRDP. But RDP's implementation right now is broken. We couldn't make it work. We couldn't reproduce. So our stuff is better. That's what I mean to say. So now, this is the advice I've just given. And here I talk about Kerberos without knowing very well what it is. But it is, I think, better. I might come back next year, I guess, with a talk on RDP with Kerberos and how to do that. I'm sorry about that. Now, now when you combine these things, you can, again, my talk clearly sounds like more on the red side than the blue side. I'm sorry about that. But when you combine these things, you can do pretty cool stuff. And this guy, Mike Felsch, amazing guy, he reached out to us and said, hey, I like what you did, and I took it in a different direction, and hear me out. And he described the attack that I'm going to talk about. It's pretty clever. It's pretty cool. So you lure someone, okay, to run, you kind of RDP fish someone. Instead of clicking on a link, he connects to an RDP system. But now he realized that RDP files exist. He was fuzzing all file types, trying to find stuff that could work. He found RDP file exist. They can provide credentials. They can map a drive in the file. They can be signed. So they have a padlock, and Windows is like, yeah, this is cool. And they can be sent by email. No one filters .rdp file. So from your email client, you double-click on an RDP file, and boom, you are connecting to a remote system that the guy specified in the RDP file, okay? And so also we assume, I don't have like super hard knowledge about this, but I assume that files created by processes that are around MSTSC, the Terminal Services Client, are not the files that the EDRs and the AVs are looking the most at, okay? I think there is a blind spot here. This is gonna be resolved eventually for sure, and we advised our clients, our own organization, to block RDP file from being sent by email. So this vector is gonna close eventually. But the cleverness is still, you double click, now the person in the perimeter goes out to an RDP system that you control, and then from that system, with a drive mapped, then from that system, you drop a file on the client side, okay? And the obvious payload is the Microsoft Teams, DLL, that you can do DLL hijacking on Microsoft Teams still today, I think. Might be wrong on that, but I think this vector still works. And so then it's executed, and you avoided a lot of the detection tradecraft that is happening right now, right? And so the full attack is documented down in this link in the slides that you guys are gonna have access to, and it's very clever, very creative, and it's not making a lot of noise, right? So I think it's still working, and it's gonna work for some time until enough people hear about it. So you still have pretty intense prerequisites. They need to have outbound access. He used Let's Encrypt for that also, to sign the file and the connection where it's going to. So pretty high attack requirements. Now the payloads that you could do once you have the target hooked on RDP, you can do DLL side loading, you can do LNK file, you can go old school, with a startup folder stuff and all that. Clipboard stealing, everything is possible here, right? Now, how can you prevent it? Block RDP files and emails, and prevent drive redirection via GPO are two things that can be done right now by most organizations. There's this blog post is actually very amazing. The guy is clearly Sysmon expert. He has like Sigma rules and stuff like that. So if you're really serious about your organization's security, regarding rogue RDP attacks, I would clearly advise to check that blog. But it's so in depth that I'm not covering this here. It's too detailed. Now, there's another thing around all this research for around RDP that I realized, and it's just how many people suck at implementing RDP. Okay. Besides MSTSC, and I'm sorry, but I haven't used the new Microsoft official client. I don't think many have, so it's not that bad. But MSTSC really is good and will remember if NLA or not NLA was used for the connection, and it will refuse to enter pre-saved credentials if there was a downgrade of some sort. Okay. Why do I know this specifically? And I tested the third-party clients. It's because we were helping a case with law enforcement where they were doing RDP interception, and they were not connecting. I was like, why is it not connecting? I don't understand. I can't reproduce this in the lab. So we tried third-party clients, and this is where I realized they suck. Most of them doesn't do that differentiation. So if you attack the RDP system by doing the downgrade to TLS instead of NLA, they don't realize it, the third-party clients. The official Microsoft client does and will not supply the credentials. So in this case, this bad guy, this adversary, online adversary, clearly was given something saved, like a pre-filled credential in an RDP file, and he could no longer connect when he was being under attack. And so this is where I had to dig in MSTSC and realize that it does make a difference for that downgrade of the protocol, which means that the third-party client are less safe than the official client. All this to say this, be careful with the third-party clients, and that's like most of them. I tested many, and most of them are problematic in that very specific perspective. Now, another area, now we left the network I/O part. Another area where RDP can be attacked is once you are on the server, credentials are stored in memory, as I mentioned at the beginning of the presentation, and they're saved, and we can dump them, right? Some of them, some of you probably already know. But so with Mimikatz, you can dump these from the memory. And the reason is because Windows tries to be kind with you. It wants to avoid you to authenticate all the time. You have like drives and stuff that are mapped. So you want to carry that authentication with you. And so this is the mistake. And so how do you prevent that? You have restricted admin, you have remote credential guard, and you have smart card authentication. And pro tip, right now PyRDP doesn't support smart card. So if you have a smart card system, we cannot attack you because I haven't implemented it because it's too fucking complicated. But so you are safer that way. But the other two, okay, remote credential guard and restricted admin are kind of it's not a Venn diagram where they touch. It's like completely different use cases. One of them is your domain joined Kerberos. The other, and this is the remote credential guard, and the other is restricted admin. You need a local account, and it's gonna rely on NTLM. So use the one that applies to your situation, and this is strongly advisable, strong advice to use that, right? And again, you know, these slides are more for reference. I don't want you to read through that, but I highlight exactly the part like why this one is interesting and why this one should be used in this context. Now, unfortunately, from the client side, it's not a default and not enforced by default. So you need to modify when you call MSTSC. So these are you know, stuff that are complicated to recommend to everyone, unfortunately. But I think Microsoft's gonna move in that direction eventually. It's gonna become a default. So the previous slide was restricted admin, and now this is a remote credential guard. You have GPO for that, of course, you know. Okay. We're wrapping up, right? It's 10:50. I have like, you know, 10 minutes of wrap up, so stay with me. So on the client, we can steal file, clipboard, keystroke, record the screen, steal hash or plain text credentials depending on the security level and if you are being downgraded or not. We have like the rogue RDP technique, which is pretty cool, which allows us to do DLL side loading on the client side, so take over the client. We can attack also the server with the same set of tool or the same protocol. We can brute force a credential, we can do a session takeover, we have common injection. In the demonstration, by the way, all of this was manual because it makes a better demo. But we know that this is not realistic for pen tests. So all of the command injection stuff is also possible to have automated. Unfortunately, you have like seconds. So it's like wait 10 seconds, execute this PowerShell. After 1 minute, close the thing, resume the connection. All of this is in PyRDP, but it's kind of has these heuristics around it that I just mentioned. And you can do also client-side credential stealing. So a lot of risks, right? But more future work than risk. I haven't looked at RDP gateway. Okay, I know it's a big gap. Because I say to people, don't use it outside of a VPN. And people are using it outside of a VPN by using RD gateway. So I need to look at this. Because if we can do the NLA attack, and I'm giving you, like, you could be famous if you implement this faster than I do. But so if RD gateway is vulnerable, this is really bad, right? Because people would rely on it as being resistant to these types of attack. I really need to take a look at it. I was playing CTF and losing instead yesterday. So the TLS work, I want to work more around it for sure. I need like net and TLM restrictions and Kerberos, all of that stuff I need to look at. And I want to take like all of the pieces of this talk and do a blog post, focus on all of the parts, you know, like bad clients and stuff like that with proof. I want to work with restricted admin on the offensive side. I have a feeling that there's a problem in it. And my feelings so far were good. So I think it fixes, the credentials are no longer available on their server, but I think there's a problem with it still. I want to try Kerberos downgrade, and I want to look at RDP gateway also from an offensive side. Now, takeaways. RDP is under the radar. If you if you are a red teamer, take a look at it. And it's not convenient. I'm not gonna lie to you. It's messy. It's slow. Not a lot of people are using it all the time, so it's tough. So it's never the top of your list, and it shouldn't be. But if you tried everything and you know that there's RDP traffic on the network, then think about it, try it. And the phishing, the rogue RDP technique is very interesting, I find. The blue team takeaway is never use RDP on unprotected networks. Now it's finished, right? It's done. Always train users not to click to the certificate error, and make sure NLA is everywhere, because not like non-NLA is too easy to attack. It's stupid, and the impact are great. So this should be looked at for any blue teamers here. And then having credential guard and restricted admin is important and should be enforced eventually. Wanted to give a big shout out to Marc-André Moreau. Marc-André is very strong. I always have doubt in my research, and he's the guy who says, yeah, no, you're on to something or not. And he works for Devolution, which is a Quebec company that works with remote management and solutions built around RDP. And and it's great to have such a smart person available and kind with me. And we don't have any monetary exchanges between him and I. It's really because I think he's kind, takes time to answer my questions. Now, PyRDP, it was done by a lot of people, and I had an idea, but a lot of people made it real, and I'm just trying to keep up with all of the stuff that is in it. But so all the names of the guys, but Maxime Carbonneau is in this room. I think I saw him earlier. He left because I was boring. Um, without them, none of this would be possible. And of course, this is fairly technical, so there's a ton of references, and all the links that you saw throughout the presentation are going to be available online soon. And with that, thanks for your presence.